Okay, so another topic in 1.7 is we learn how to graph a union or an intersection of sets. So now set that we learned in 1.7 here is an interval. An interval is a set. And so now how we can graph these. In example number 1, let's say we have two sets. One set is the interval for values between -3 and 0, and the other set is -1, 2. And let's say we're trying to graph. So here we have an open interval and we have a closed interval, and we want to find the intersections. Okay? So how can we graph that intersections? So keep in mind the way how we say this is an intersection. Okay? So how we can graph this intersection? Okay? Always think for yourself, draw for yourself two lines. Okay? And kind of make the numbers here kind of lining up together. So on the first line is to be the graph for the first interval. So the first interval is -3 and -2, -1, and 0 is somewhere here. And the next one here, interval. For the next interval, we have -1, 0, 1, and 2. It's about here. Okay? So now, just shading on each line here according to its interval. So now the first interval we have is in between -3 and 0. So now I'm shading in between -3 and 0. And I'm leaving this parentheses because we're having an open parentheses, open interval there. Now for the second interval, is the shading in between -1 and 2, and also I want to include -1 and -2. So now to graph the intersection of these two, what you need to do is draw for yourself the third line, and thinking about the third line here as the superimpose. Think about when you're trying to superimpose these two lines together, bring them together. Where is going to be the overlapping regions? Now, the overlapping portion would be in between -1 and 0, isn't it? So here I can find my overlapping, -1 and 0. So all that overlap will happen in between here. That's the overlapping. And so now, let's say, how do we decide? How can I decide the interval ending here? So now on the left end of that overlapping, it looks like we're going to have to use. So on the first line, is the value inside? I mean, on the first shading right here, do we also shade that is -1? The ending point right here is -1 included in the first interval? Yes, it is. Is -1 also included in the second interval? Yes, it is. So now in the third one, in the overlapping, of course, it's also going to be included. Okay. Now the other ending, which is the 0. So now if you check back with the first interval, 0 was not included in the first interval. And so now it doesn't matter if it's included in the second interval. 0 is just not included in the overlapping, because 0 is only included in the second one, in the second line, but not in the first line. So in the overall line, in the overlapping, 0 is not included. So now this is the graph of my intersections. So the interval will be from -1 to 0, and like that. Now same example with the two. How about with the two intervals here? Let's try to do the intersections. -3, 0, and the same interval, -2, 2. I mean -1, 2, and this time we want to do the unions. Here's the union, and the sign for that is the upside cut. Once again, draw for yourself two lines first. Each line represents an interval, the graph for an interval. So here I have -3, -2, -1, 0, 1, and 2. And here I have So my first interval shading is in between -3 and 0, and leaving parentheses around -3 and -0. The next one here I have closed interval with brackets in between these, just like that. But now this time, to find a union, create for yourself the third line once again, with all the points laid out. But then think about when you unions. Now to create the unions, think about when you bring these two lines together, when you superimpose these two lines together, wherever the two regions together extend to, that is going to be your union. So hear my words again. Anywhere that anywhere that the two regions together extend to, that is how far your union is going to reach. And so including the overlapping, the union this time is going to reach all the way from -3, because this is where it starts, and here's where it ends. No more after those, no more beyond those. So here's from -3 to +2. Okay, so we shade everything in between. Okay, and then here's for the ending point. Once again, consider for yourself. Okay, is 2 here in one of the set? Yes, 2 is in one of the set, and 2 is included in this one, so it should be close bracket here, and here's on this left end right here. The far end, it's that one. Okay, so that's how we draw the union. So now the idea about the union here is just the shading on the top one extend as far as -3. The shading on the second one extend as far as to +2. So together, that's how far the two shading together extend to. That's how far the union is going to cover up to. So that's how you find the union. Okay, so let's look at the second example. So in my second example, okay, so here we have the two intervals, -∞ to 5, and then the other interval is 1, 8, half open interval. And so let's try to find the intersections. So we need to graph. So how about -∞ to 5 and intersecting with 1, 8. Oops, wrong 8. 1, 8. So now, once again, draw for yourself 2 lines. Each line represents an interval. So the top interval here is for this one, 5, maybe somewhere here. That's 5. Okay. And so the first interval is indicating that -∞ to 5. So anywhere less than 5. Okay. And then we are using parentheses here on 5. Okay. Now, on the second interval, 1 is somewhere to the left side of 5. So 1 is here, 5 is there, 8 is somewhere here. Right? And we want an interval in between 1 and 8. So that's how I'm shading it in. And here, according to the interval, we have brackets on 1 and parentheses on 8. Right? So now, once again, to find the intersection, draw for yourself the third line, and imagine the third line here comes from the superimposing of the first two lines together. So the top and the second line, when you superimpose them, when you bring them together, what's going to happen? Where's the overlapping? The overlapping is going to happen just simply in between 1 and 5 only. So here's my overlapping. 1 and 5. Okay, and then let's decide about the ending point here. Now, my left end for this overlapping is a 1. Now, is 1 included in the first set? Yes, 1 is included in the first set. Is 1 also included in my second line? Yes, it is. So here in the third one, it's also included. Is 5 included in the first one? No, but 5 is included in the second one. So, meaning 5 is only included in the, so that means 5 is not included in the overlapping. So the point is, as long as the ending only included in one line, as long as the ending here is not included in any of the regions, the overall one, the overlapping one has to be a parentheses. So there, I'm seeing that 5 is a parenthesis there. So now, let's try again with these two intervals, and we try to get the union. 1 to 8, and try to get the union this time. And once again, I'm thinking about trying for myself 2 lines. Okay. Here's 5, and I want anywhere less than 5. Okay. And here's 1, and here's 8. So, to draw the unions, once again, taking the unions of these two is the same as, once again, imagine that you superimpose these 2 lines together. But this time, we're going to look for wherever the 2 shaded areas reach, extend to. So, when you superimpose these, the 2 shading areas together, it reaches all the way up to 8. 8 is the furthest reach to the right, and negative infinity is the furthest reach to the left. So here's how it goes. Okay? And so, and the 8 here is not. Okay? So now the 8 here, I'm going to have to use parentheses, because 8 is not included in this one, and 8 is not included in the other one. So of course, in the overall 8 is not included. The end point for 8 is not included. So that's how I get the unions for the 2 intervals here. So one more example.